my name is Claus Ibsen, and this is my first time here in Belarus, so thank you for inviting me. I'm a software engineer from Red Hat. I've been working with Apache Camel for 10 years. That's a very long time. Wrote a couple of books on Camel. This talk is usually 1 hour, so I have to go a bit fast. And cut the demo a bit short, so sorry for that. And speaking of Camel, please raise hand if you have used Camel or are using Camel. So for the video, that's maybe 5 people, 10 people or so that's good. So there's plenty of people here that don't know about Camel, so let me introduce you to Apache Camel. So what do you use Camel for? Well, Camel is used for system integration or integration. So Camel is kind of like that software piece that sits between the systems to integrate them. We like to define Camel as an integration framework, and it's based on enterprise integration patterns. So those two words, let's take a look at those. As an integration framework, I like to illustrate Camel as a toolbox that has ready-made tools for you as a developer to use to build your integration. So you as a developer should not need to reinvent the wheel and write your own tools. So Camel sort of allows you to work at a higher level, and Camel abstracts away all the low-level details. Now, what is enterprise integration patterns? Well, that's in fact a book. It's a thick American book, 800 pages, with that same title. The authors of the book, Gregor Hobby and Bobby Wolf, were a consultant that went from client to client and helping with integration and system integration. And what they saw was the same problem occurring over and over again. So what they did was to write down notes about these problems and how to solve them, and came up with a vocabulary about these things. And over time, they accumulated so many notes that the idea of formalizing that into a book came to life. That's a good thing. The book was published 13 years ago, and we regard it as the integration Bible. In this book, we have recipes or integration patterns for solving common integration problems. So there's one called content-based router. It's like an if-else. You can filter messages, you can send messages to a number of recipients, you can split, you can aggregate, and so on and so on. The book has 65 patterns. But what about? That is just a book. And how is Apache Camel? Well, Apache Camel implemented those patterns, so you can use these patterns. So let's take a look at that. In Camel, you define how systems are integrated using routes or integration flows. In these routes, you can use the patterns. Here are very basic routes in Camel. One is, the top one is Java, and the second one is XML. So we're just saying we want to consume files and send it to a message queue. So that's 2 lines of code. Now let's make a little more example. So I know it's quite common still to exchange data using files. So let's assume you need to pick up a file, split the file line by line, do some sort of message transformation on each line, and each line to XML, and then send that message to a downstream message queuing system for further processing. So with the book, there are like 4 patterns you can use. Illustrate that on a whiteboard, for example. But what we like to do is also to write down using English words. So in Camel, you can do this with the Camel DSL. So you can just say from file, we need to do a split. And then we need to split the message body using a tokenizer. And the tokenizer is the new line character. So you split it line by line. Then we do some sort of message transformation using a Marshall from some sort of custom format to XML. This is where you write some code yourself because it's a custom format. And then you can send that message XML to a message queue named line, for example. So 4 patterns from the book can correspond to 4 lines of code with Camel. What about the architecture of Camel? So this is the only illustration you need to know. This is the high-level figure of Camel. So in the center, we have Camel context. Camel context is Camel. It's the runtime Camel. So the idea is that you can add routes to these contexts, and in these routes, you can use these enterprise patterns where you can do routing, transformation, validation, call custom business logic, and so on and so on. And then on the bottom, we have Camel components, which you use to connect to different systems or to speak to the outside world, as I said. So that's it. Where can you run Camel? Well, you can actually run Camel everywhere or anywhere. Camel is a Java technology, so wherever you can run Java, you can run Camel. Now, Camel was created 11 years ago. Yeah, that's a long time in the software industry, but it's also proven track record of being a stable and mature product that has a constant release and a huge user base. So in the older days, we used to build Camel application or integration application more using application servers like IBM and Oracle and JBoss and so on, and build WAR files and throw it over to the operations team. But in recent time, and more related to this talk, we are talking about containers and cloud technologies with microservices. And Camel runs well in both worlds. Now, Camel can connect to many things. It comes in more than 200 components, as we call them. We have your traditional enterprise system with files, the databases and whatnot, socket networking, public cloud from the big vendors like Amazon and Google and Microsoft Azure, software as a service offerings from Salesforce, SAP, LinkedIn, and social media and whatnot. And also in the corner, there's maybe an area you may not know that Camel can be used as well, is IoT world. So now you say, okay, Camel, are you really saying Camel is running on my smartwatch or small embedded devices and whatnot? Well, of course not. Camel runs on Java, and Java is too heavy for that. But in the IoT world, it's very often that you have a sort of like a gateway in between your embedded devices that connect to a gateway, which is small computing, and then the gateway can relay those messages to a backend system. And on the gateway, that is powerful enough to run Java, and in there it can make sense to have Camel. It has easy connectors for all these low-level connections in the IoT world, like MQTT and so on, and then you can use other protocols to send to the backend. So we see today Camel used in all 4 areas with success, and sometimes also with failure. Okay, so just to highlight what Camel is in pictures, if you may have to tell other people, it's that toolbox. Then you have enterprise integration patterns, from that big book. Then you use those patterns to define Camel routes, how to integrate different systems. And then you have all these components to connect to the different systems. All that together is Camel. Okay. So now let's change topic a bit, or focus a bit on this talk. What about Camel in the cloud? Or when I say cloud, I mean running Camel on containers on Kubernetes, for example. I just use cloud because I found a very nice photo of a cloud that is shaped of a camel. So, okay, but cloud and containers is also with a C, right? So when we start to run applications as containers, we are moving from a more monolithic application to a more microservice architecture style, where we split out our bigger monolithic application into smaller pieces known as microservices. Then over time, these microservices become more independent. They become distributed, and they also become networked. So now we have a different situation with distributed computing. So now we have different services running on different hosts, on different nodes, communicating over the network, running in containers and whatnot. Is quite more complicated than just one big monolithic application. So why are we doing this, and how can we run our applications as a microservice in a reliable, fault-tolerant, scalable, elastic way? Well, we need a set of features or capabilities that can assist and help us to run our application in such a safe way. So where do we get these from, and what do we need? So we need a set of microservice utilities, if you want to have a fun word. So here's some of those we need. It's a shape of 10. It's a decagon. So where do we get these features from? Well, we get many of them from a container platform like Kubernetes. So Kubernetes makes it very easy for service to discover service. It makes it easy to invoke service, and also make it easy to scale up and down your microservice in a flexible and scalable way. But developers in companies, they often need extra service, And you can say on a container platform, you can add on top of that, known as a platform as a service. You can, features like pipelines. So you have CI/CD for developers to build applications that can run through a pipeline with different testing and staging and so on. You also need for ops people to be able to have centralized logging so they can access the log and see what's going on in the logs and monitor your microservice and whatnot. Also on top of that, there is a new product coming around called Istio in the space of what is called service mesh. Istio is gaining momentum and is very interesting to take a look at. So Istio tries to be a solution for connecting service in a more secure and fault-tolerant way. So it has features around resiliencies and authentication and also related to tracing and even APIs. So keep an eye on Istio. When you start to have a lot of microservices with APIs, you lose oversight of all these APIs. So you may want to have an API management solution that can help with a service registry for developers to take a look at, to read about those services and APIs, and also they can get access to their service contract, like in Swagger documentation and so on. Also, if you get to the point where you need to hand out API tokens for people to access these services, and you may have policies around rate limiting and security and many other things, then it makes sense to start to have an API management solution in the mix as well. But this is a Camel talk. So where is Camel? Is it gone? But I said it works well in the cloud. No, it is embedded in your service. So we have Camel in the center. Yay! So Camel can run in your service embedded together with this microservice. It requires Java, so it's only the Java service like Spring Boot, Vertex, Wildfire Swarm, and other Java technologies. So you can't use Camel with Go. Sorry. But you can use Camel with Kotlin in Java. So when you talk about microservices that are distributed, and when you have integration needs, then you have distributed integration. And the idea with Camel is that you only take Camel where you need it. So for example, here we have 3 services, A, B, and C. And here it only makes sense to use Camel apparently only in A and C. And for example, in C, service C, you may need to communicate to an external system outside the platform or the cluster. And that can make very good sense to use Camel because Camel comes with more than 200 components, so it makes it easy to connect to different external systems. For example, the external system could be a legacy system, it could be an Oracle database or whatnot. Camel has components for DBC, SQL, and so on. So that's where it can make sense. So when you start to run Camel in the cloud, cloud again as a containers, what are some of the good practice around doing so? Well, you should be small in size. Camel is lightweight, also from the beginning 11 years ago. So the idea with Camel is that you have a Camel core, and then you just add the dependencies you need, the Camel components with their dependencies. So you don't get a big bloated application. I will have to say that the next generation of Camel, Camel 3, which we're going to announce more in the public data this year, it will be even smaller with more modularized Camel core, so it can be even smaller than that. But a good practice on microservices is also to run these microservices as a single fat jar kind of thing, where there are different runtimes that can help with that, Spring Boot and so on. And Camel works great with those. Another thing to aim is to try to build your microservices as a stateless application. They are much easier for the platform to scale and manage. But if you need some sort of state, Camel has integration with different memory data grids like memory systems like InfiniSpan, Hazelcast, also for persistent storage. And then the container platform Kubernetes also has a concept for stateful application called stateful set. So you can use that. Another practice is around configuration management. So when you build microservices as containers, you're actually building those as a Docker image, a static Docker image. So the intention is that the image and your configuration are separated. So configuration management, you need to externalize your configuration from those images. And Kubernetes has two concepts for that. One is called config map, and the other one is called secret. They're actually similar in size, so the information for those are like a key-value pair. And you can get access to these configuration either as injected to your container as environmental variables or as files. So it can create files in the file system in the container. So secrets, you use those for sensitive data like password and certificates and so on. And in Camel and Spring Boot and so on, it's easy to access those configuration management where you can refer to the name of the key. In Spring Boot, is this add value. And in Camel, we also have similar feature, but it's just using double squirrely parentheses. Another really powerful practice you need to work with is around fault tolerance. You need to build your application as fault tolerance, and we're going to see that in a demo. Errors can happen, errors will happen. The law of Murphy is there. What can go wrong will go wrong. So there's sort of like two processes for handling errors. One is about retries or client-side retries, so you can invoke a service and try again. Another popular one in microservices is around circuit breakers, and Camel has support for both, and we see that. So for retries, for example, we have here on the slide, Camel is calling a service, a hello service, so the first time it fails, you just invoke it again, and then maybe the fourth time it works. That's a good approach in some use cases, but you have to be aware that it prolongs the invocation. Whatever the client that called that one have to wait 4 times invoking that service before it actually eventually worked. It works for some use case, but not for everything. Now, imagine that you have a microservice, a downstream service where upstream are calling it, and they're using retries. And that downstream service in the center here, the relevance one, is under stress. It cannot handle all that load, so it keeps failing. Then it doesn't really matter, help that you just keep retry. You just make it extra worse for it. That's known as the thundering herd problem. A group of cows or herds that come running towards you. You cannot stop them. So this is dangerous. Another practice is definitely around microservices. You need health checks, or so the container platform knows about the state of your applications, know whether they're healthy or not. So Kubernetes comes with 2 concepts for that, probes. There's the readiness probe and the liveness probe. They are similar concepts, but the readiness probe is used for usually around starting up your application and to signal when it's really ready to handle traffic, and only at that time Kubernetes will send traffic to it. Liveness probe is constantly call your application to check whether or not it's still alive, because an application can maybe over time in a Java JVM start to satur and get slower and slower, maybe start to run out of memory or whatnot, and then it crumble, and then maybe the liveness probe can say, I'm no longer live. And then the container platform will know that, and it can try to restart or create a container running on a different host or something like that. These are very important, and they come easily with Spring Boot and other containers like Wildfire Swarm. Camel integrates that easily with Spring Boot, so you just have Spring Boot actuators, you add Camel to it, and Camel blend into that, as you can see on the slide here. What about all these enterprise integration patterns? Are there any worries about using those with cloud and container technologies? No, they are universal patterns. Those patterns were created 13 years ago, before there were Kubernetes, before there were really cloud and whatnot, but they work beautiful there, so just go and use them. No problem. So now we're coming back to that fault tolerance around circuit breakers or error handling. So there's a very famous implementation in Java from the Netflix guys called Hystrix. And Camel has great integration with that, which we're going to see in the demo. So the intention is that you can just tell Camel, okay, Hystrix, and everything you do inside that block is protected by Hystrix in the circuit breaker and handled by that. And then you can have a fallback And here, for example, if calling that my service fails, then you execute the fallback. That works for some situations, not all use cases. For example, if you have a money transfer, I'm sending you some money, and if it fails, it just says, okay, that's not good, you never get the money. But in other use cases, like a web shop, where we have some sort of microservice that says other users are looking at, or I will recommend it, or top, whatever. If that fails, you can just have some sort of default, and that's okay in those situations. There's also around microservice, around distributed transactions. In the classic world, on Java, for Java E, we had XA transaction and transaction manager from the platform. We can do with JWC and JMS. When we have microservice and distributed, we don't really have that anymore. But there is a pattern for that called the Saga pattern, and Camel integrates that as well. So you can use Saga and let an external orchestration engine handle that distributed transaction by executing that and then do undos and whatnot. And the guys that may have been here at the workshop yesterday, we implemented and used that and saw that. One last piece is also around distributed tracing. When you have a lot of microservice going on, one thing is like a business use case, a business transaction that touches many microservices. How do you know what's going on? So you need a strategy for being able to figure that out. So the idea is that you can leave some sort of breadcrumbs that trans across all these microservices, and then there's sort of like a centralized UI that can pick them up and visualize that for you. There are two open source projects around that, Zipkin and Open Tracing. Camel integrates with both of them, and you can use a dashboard like Jaeger UI. It came from Uber. And so when you have this decagon again, so where are some of these capabilities you get from Camel? For APIs, there's a REST support from Camel. Camel components make it very easy to invoke other service. You have some strategies with Camel around resiliency, with retries and historics, and distributed tracing, and so on. So now we are getting towards a demo. So this is a very simple demo. So we have a client that calls the service, a hello service, using HTTP and get a response. The client is just invoked every second using circuit breaker with historics. If there's an error, it will say nobody wants to talk to me and log that. And the server kind of thing is just accessing the HTTP call and executing a Java bean method, say hello, where it says swarm says hello from, and then we get the host name. So it's dynamic. So now I will exit the slides and go and see here. I already have a local cluster running, so if I reload this page, I should be able to get a response. Swarm says hello from, and you can see the name is kind of dynamic. If you go to a terminal, I can see here which parts I have running, the client, the swarm, and so on. So I can just say follow the logs from the client. Logs, client. Cluster, kubectl logs, follow, client, historics. That's tab completion. So now it will log in the top terminal, and I'll just say delete pod hello swarm tree. So what I'm doing now is to delete the hello swarm or the hello service, and the client keep calling it. You can see the circuit breaker kicks in and say nobody wants to talk to me, and then hopefully the service should come back up online again, and it should get a response. And now it gets a response, and pay attention to the return response is a different host name. So that's one way of building a bit of resiliency into your application. But now you say, okay, there's only one container running with that service. Why can't we just have two or more? So if one dies, you should just call the other one. A very good idea. So let's look at the logs. This is one also following the logs. So now I will go to a web console and scale it up. Where's the mouse here? I'll just say here, this is easy a bit with this guy. So hello swarm, there's one. I'll just go to 2 and go and see here. Oops, what? Yes, now it's calling, right? So we get some response, now scaling up to 2. There's 3, the host name. Oh, now pay attention, now there are 2 different host names. And so now we scale 1 from 1 to 2, that's successful, but okay, why did we get an error? You're actually using a container platform. Why can't it be more fault tolerant and safe to scale from 1 to 2 without getting errors in the client? Well, the reason is there's no, so when you scale up an application, you start up a new container, and Java takes time to start up. And only when it's fully started up and ready, you want to say to Kubernetes, okay, I can get traffic, I'm ready. So what I on purposely did was to not have any readiness check in that container. So it was just ready immediately. And then Kubernetes started to call it. But Java was starting up, so it would get an error. That was on purpose, but it was to illustrate to you guys, you have to implement readiness check and health checks on when you have a service, and also on when you call service in the cluster, you have to have retries or circuit breakers, because errors can happen, even though the platform tries as its best. So now we have 2. So what we can do is to go back to 1, and then I want to illustrate here at the end just a very simple. You can also monitor your circuit breakers using a dashboard from Hystrix. So now everything is good. It's green. So green is good, and red is bad. So if you go down here and just kill the container again, yes. Now it's going to be deleted, and we can see the dashboard should start to detect that there are some errors. Now it flips over, so it's open, it's red, it's bad, and we get the response. 100% of the requests are failing, so it will go for a while, and now it starts to become open again, and we get back to 100% green in a moment. I am running out of time, so I am getting quickly back to the slides, so we can just continue a bit, and then we take questions. So when you start to work with container technologies, there's a lot of new information to learn. You're not supposed to read this slide, but this is a great triangle with some good concepts to learn. If you read the slide, if you download the slides, you can find out more information. Some books around this. So as a Java developer, if you want to build microservice for containers and whatnot, there's a free book here. There's another one around Istio. And then there's also a book but it's not so free, Kubernetes in Action, awesome book. There's also Istio in Action, it's currently being authored, it's not published yet. And then there's the best book in all, Camel in Action, my book. It's published in February this year, so it's brand new, 2nd edition. It's a small book, it's the quick start, it's only 900 pages. There's a discount code, Camel39, 39%, it works all the time. Sometimes the publisher gives you bigger discount, 50%, 60%. So maybe you can try Camel 99, 98, 97, and maybe you trigger it, maybe you're lucky. So where can you find more information on the slides? I have it on my GitHub account, Claus, Camel Writers in the Cloud. This is called the theme of this talk. They're like a branch for different conferences I went to, so find JFuture there. And that's it, we go to Q&A.
Cool. So we get a few questions. First, a joke from workshop. Shut up, Claus. We want to go home.
Yeah, you were there yesterday. I want to go home too. I'll go home tomorrow. So no, I want to see more.
Quick question, yes or no? I see many mentions on Spring during this talk. So is it Spring necessary for Camel?
No, Spring is absolutely not necessary for Camel. Camel is a neutral library. It's just a file. You can run it with Spring, without Spring, standalone, Java EE, whatever you want to use. Spring is not necessary. The demo was actually using Spring Boot, and the other one was Wildfire Swarm. So you have total freedom. Okay,
and who is Camel competitors? So like maybe Ultra ESB or Spring integration?
So the classic competitors for Camel will be Spring integration, or it used to be a Mule. But Mule was acquired by a company, and they are in a bit. They're not really open source. Spring integration will be the, but Camel is really awesome. Then the big vendors, right? But nobody used that anymore.
Okay, maybe someone from auditory like to ask something? No? Okay, thanks.
Okay, yeah.